Hello everyone, so today we will start our new chapter, that is vector algebra. So first of all, to learn about vectors you must know about this diagram. So this diagram tells about this is x-axis, this is y-axis, and this is z-axis. And I am considering a vector r, that this is a vector r, and this is going to point P, which coordinates are x comma y comma z, and this is origin from where the vector starts. So you can take this also as x-axis and this as y-axis, or this as z-axis, but for simplification purpose we use this as x, this is y, and this as z. So a vector r is such that its tail is at origin and its head is at point x comma y comma z. This is called head and this is called as tail of the vector. And vector, you must know what are vector quantities and what are scalar quantities. A vector quantities has both magnitude as well as direction in this direction, and the scalar quantities has only magnitude, not direction. So this is initial point, and where it ends is terminal point. The point O from where the vector OP starts is called its initial point, and the point P where it ends is called its terminal point. And the distance between initial and terminal points of a vector is called its magnitude. So this is called magnitude, that is mod r. It is magnitude of vector OP. And what is the value of mod r? It will be under root distance between O and P. So it will be x square plus y square plus z square. And this arrow point indicates the direction of the vector. So a vector quantities has always this arrow point above it. So now we will learn about types of vectors. So there are different types of vectors based on its position and its magnitude. So first one is zero vector. So what is zero vector? If the initial point and the terminal points coincide, that is this is a zero vector. That is, its magnitude is always zero. So I can write magnitude is always zero. And second thing is, you can't define the direction of a zero vector because it is point. It is like point, so you can't decide where it is going. It is whether it is going this direction or this direction. So the direction of a zero vector can't be assigned. Second is unit vector. So in a unit vector, magnitude is always 1. Always 1, or you can say unity. The direction of unit vector is always assigned by cap, I cap. So I cap example is I cap, j cap, or k cap. Further you will learn that x-axis is called I cap, unit vector of x-axis, and y-axis j cap, and z-axis k cap. So it is represented by cap of unit vectors. For example, a vector A is given, and you will first of all, to find the direction, you will first of all give the unit vector, and then you will assign a cap or whatever it is, I cap, j cap, and k cap for x's. Third one is co-initial vectors. It is already defined that the vectors which have same initial points. For example, this is a point and more than one vectors are initialing from the same point, starting from the same point. So these are all co-initial vectors having same initial point. Fourth one is collinear vectors. So two or more vectors are collinear if they are parallel to the same line irrespective of their magnitude and directions. For example, if this is a vector A, then if other vector is parallel to this vector, which is may or may not be equal to its magnitude, but in the same direction parallel to this is B vector, so they both are collinear. And this also may or may not be in the same direction. So this is vector This is also collinear. The both directions are opposite, but there are also collinear vectors. Fifth is equal vectors. So vectors are said to be equal if they have same magnitude and direction, regardless of their position of initial point. So if the two vectors are in the same direction and also parallel to each other, so I can write this is a vector and this is b vector, and they are in the same direction and also their magnitude is same. So I can write a vector is equal to v vector. So they both are equal. Their magnitude is equal and their direction is equal. So they both are same. The thing you must keep in your mind is their initial points may or may not be same. So it doesn't depend whether the vector is here or here, but their magnitude and direction is same. So I can write a vector is b vector. Sixth is negative of a vector. So how can we find negative of a vector? So let's consider this is vector a, and if I write a vector as minus a vector, then its direction will be reversed. If it is going in this direction, this will be in this direction. Its magnitude will remain same, but its direction will be get reversed. If it is going in right hand side, then minus a will go left hand side. Let's consider this initial point as a and this as b. So this will be b and a. So I can write b ab vector is equal to minus ba vector. So now we will learn some operations on vectors. First is addition of vectors. So if two vectors are given, so it is called triangle law of vector addition. Let's consider this as triangle ABC, where AB is a vector, BC is a vector, and AC is a vector. So I can write AC as AC vector as AB vector plus BC vector. So this is AB vector, this is BC vector, and this the addition of both these vectors will be give us AC vectors, and this is called as triangle law of vector addition, because this is forming a triangle where AB is a vector, BC is a vector, and the initial point of AB vector and the final points of BC vector, if we add these 2 points, we will get the sum of AB vector and BC vector. So first is exercise. This is exercise 10.1 from NCERT. So this is a graphical question. You have to represent graphically displacement of 40 kilometer 30 degree east of north. So 30 degree east of north. So north direction will be this, and 30 degree east. So this will be east 30 degree. Second is classify the following measures as scalars and vectors. So you have to find whether the quantity is scalar or vector. So first is 10 kg. So kilogram weight. This is weight. So mass. So mass is a scalar quantity. This will be scalar. 2 meters northwest. Magnitude is given and particular direction is given. That 2 meters in northwest direction. So it will be vector quantity. Third is 40 degree. So angle is in scalar quantity. So 40 degree, your direction is not given, 40 degree east, 40 degree west, or 40 degree from x-axis. So this is scalar. 40 watt. So watt. So this is also unit of power, watt. So this is scalar quantity. Fifth is 10 raised to power minus 19 coulomb. So coulomb is a unit of this energy, electric current. So electric current is scalar quantity. Sixth is 20 meter per second square. So this is acceleration. So acceleration is a vector quantity. Sixth is vector quantity. Now third question, classify the following as scalar and vector quantities. Same. So time period is scalar quantity. Distance is also scalar quantity. Third is force is a vector quantity, because both in which direction the force is applied, it also depends. Third is vector quantity. Force is vector. Fourth is velocity. So velocity is also vector quantity, but speed is scalar quantity. Fifth is work is scalar because work done doesn't depends on which direction. So if I say let's 20 watt of work is done, so it doesn't depend on the direction. It is scalar quantity. Fourth is identify the following vectors co-initial. So co-initial vectors are which have same initial point. So vector A and vector D are co-initial points because they have same initial points. This is going this direction and this is going in down direction. Second is equal vectors. So equal vectors are those vectors which have same direction and same magnitude. So vector D and vector B are equal vectors because it is a square, so all the sides of square are same magnitude, and this are also going in this direction and this is also going in this direction, so these are equal vectors. Third is collinear but not equal. So collinear vectors are which are parallel to each other but may not have same magnitude. So collinear vectors are which are parallel and irrespective of their direction. So their direction may not be equal. So A and C vectors are collinear. They are equal. So it is collinear is may or may not be equal. So these are A and C are collinear vectors and B and D are collinear vectors. Fifth is answer the following as true and false. A vectors and minus A vector are collinear. So yes, it is true because if A vector is this, so minus A vector will be this. So they are parallel. So if they are parallel, then they are collinear. Second is two collinear vectors are always equal in magnitude. So this is false because collinear vectors are always parallel irrespective of their direction and magnitude. So their direction is may or may not be, their magnitude may or may not be equal. So this is false. Third is two vectors having same magnitude are collinear. So this is also not true. This is false because their magnitude may or may not be equal. Two collinear vectors having the same magnitude are equal. No, this is also false because their direction should also be parallel to each other. They must be parallel. If I say this is vector A, this is vector B, they both have same magnitude but they are not parallel to each other, so they can't be collinear vectors. So they must be parallel to each other for collinear to be true. So these are some of the properties of vector addition. Property 1 is for any two vectors A and B, A vector plus B vector is equal to B vector plus A vector. So this is commutative property. So commutative property holds true for vector addition of two vectors. So this is parallelogram law of vector addition. If this is a parallelogram, if this is A vector, this is B vector, then its diagonal will be A vector plus B vector, or you can say B vector plus A vector because commutative properties holds true. So this is also parallelogram law of vector addition, and this diagonal represent this vector of some addition of A vector and B vector. Second property is for any three vectors A, B vector, and C vector, A vector plus B vector close bracket plus C vector is equal to A vector plus B vector plus this bracket B vector plus C vector. So this is associative property. This is also true for three vectors. The sum of these two vectors plus this third vector C vector is equal to A vector plus sum of these two vectors. This is multiplication of a vector by a scalar quantity. So if I consider this as A vector, so if I multiply it by half, so it will be this magnitude will be half. If this is this of this much length, then it will be half. This magnitude will be half. If this is I will multiply by 2A, then the magnitude will also multiply by 2. So its length will increase. If I multiply it by minus half of A, then its direction will be reversed. If this is going in up direction, then it will go in down direction. You can say this is half of A and this is of minus half of A, and this is of minus 2A. Its magnitude will increase but its direction will change. And we represent a unit vector by, let's consider this is a vector A. So the unit vector of this vector will be, I will write A cap is equal to A vector divided by magnitude of A vector. So let's consider if this vector is 4 I cap plus 2 k cap minus 3 j cap, so its unit vector will be a cap is equal to 4 I cap plus 2 k cap minus 3 j cap divided by its magnitude. Its magnitude will be under root 4 square plus 2 square plus 3 square, which will give us the value 4 I cap plus 2 j cap. This is j and this is k. So 2 j cap minus 3 k cap upon 4 square plus 2 square plus 3 square will be, this is 9 plus 4 plus 16. This will give us 29 under root 29. So the unit vector will be 4 upon root 29 I cap plus 2 upon root 29 j cap minus 3 upon root 29 k cap. So this will be its unit vector of a vector. So thank you everyone. Please like, share and subscribe, and Jai Hind.